Good day, viewers. Welcome to Brainstorm Tutors. My name is Sahid Ogundeji. Today, we want to look into this question. This question is being adopted from WAEC 2015 and it's all about trigonometry. And under this trigonometry section, we are actually emphasizing on angles of elevation and depression. Now, let's solve this problem. They said, without using mathematical tables or calculator, simplify 2 tan 60 plus cos 30 over sin 60. It's very simple. Whenever you come across any special angles, they are kind of angle that you can actually obtain without using tables or calculator. Now, to find the value of 60, 30, we use what we call an equilateral triangle. We all know that all angles of what? Of an equilateral triangle is equals to what? 60 degrees. The included angle of an equilateral triangle is equals to 60 degrees. Here is 60, here is 60, here is 60. So they now make this triangle a 2 units. Like all the side is going to be 2 units. So now if I draw a perpendicular line that is from this point to this, if I draw a perpendicular line, so this perpendicular line will bisect this what? This side, let's call this side A, B, C. It will bisect this line BC into 2 equal parts. So it will bisect into 2 equal units. Let's assume this is 1 unit, another 1 unit. So let's call these midpoints M. Now, also this perpendicular line will also bisect this angle 60 degrees into 2 equal parts. Here will becomes 30 degrees and this side also will become 30 degrees. So with this angle that we have here, we can use Pythagoras theorem to get the value of my AM. My AM is going to be equals to what? Root 3. So now you can actually find that using Pythagoras theorem, just like when we have something like this. Here is 60 degrees. I just bring out this triangle ABM because this kind of triangle is a congruous triangle. What I have for ABM is going to be the same thing that I'm going to have for ACM. So I just bring out the triangle ABM, a right angle triangle. Remember, the angle I have here is now 30 degrees. If I use Pythagoras theorem, I'm going to get this to be what? Root 3. And don't forget, this side is 2 and this side is 1 unit. So with this angle that triangle that I have here, I can find the value of my sin 60, cos 60, tan 60. The same thing also goes with the one of 30 degrees also. We all know that where this angle is facing is my opposite. I want to emphasize to look for the value of tan 60, sin 60 first. So now I'm considering the triangle ABM. So where this angle is facing is my opposite. Where the what root of this angle is facing is my hypotenuse and the downside is my adjacent. I think you all know how we get this place. So okay, let me just show you how we obtain this place. Let's assume here is X. So remember, this is a right angle triangle, and according to the Pythagoras theorem, it said that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other opposite side. So here I can say that hypotenuse square equals to what? Opposite square plus adjacent square. I just want to show us how they get that place to be root 3. It's not by magic. Now we say that this is what? 2 square equals to my opposite is what? X square. That's what we are looking for. Plus my adjacent is what? 1 square. So 2 square will give me 4 equals to x squared. 1 square will give me 1. So I'll collect the like sign. When this plus 1 is crossing the equality to change to minus 1 equals to x squared. I can also do that x equals to square root of what? 3, because 4 minus 1 will give me 3. And when this square is going to that side, to change to what? Square root of 3. So that's all about that. That the reason why we get this x to be equals to root 3. And we can use it to find any value for sine of an angle, cosine of an angle, and we're going to obtain the same thing as if we check our tables or we use our calculators. So as simple as that, that is how we're able to obtain this right angle triangle. So now let us use this to find the value of my sine, cosine, and tan. So now here, what I'm after here, I'm after tan 60 and sin 60. So here I'm using this. That is where this one is facing my opposite. The longest side, or the side where this right angle is facing, is my hypotenuse, and the downside is my adjacent. So I'm using what? I'm looking for tan. I know that tan 60 is going to be equals to opposite over adjacent. So I have it to be root 3 over 1, which is still similar as what? Root 3. Also, I need to look for sine 60. Sine 60 is going to be equals to opposite over hypotenuse. That is what? Root 3 over 2. Remember, my hypotenuse is 2. So we have been able to find the value of tan 60 and sine 60. We made the value of cos 30. And remember, if I'm dealing with cos 30, I will need to clean all what we have here. I'll clean this. I'll place this. Now, I'm here. I'm going to focus on what? This 30 degree. So where this angle is facing, it now becomes my what? Opposite. That means where this angle 30 degree is pointing out, is facing, becomes my opposite. My longest side is my hypotenuse, it still remain the same, and the third side is what? Is my adjacent, because I'm considering this angle 30 degree. So where it is facing will become my opposite. The longest side will become my hypotenuse, and the downside will become my what? Adjacent. So now here, I need to look for what? Cos 30 degree. Remember, cos of an angle equals to adjacent all over hypotenuse. So what's my adjacent side here? My adjacent is root 3. Then my hypotenuse is what? 2. So that's all about that. So what we are going to do now, after we have obtained the value of this and this, we just substitute it in the what? In the original function. So now my original function becomes 2. Instead of me to put tan 60, I'm going to multiply by tan 60. What's the value of my tan 60? That is root 3 plus cos 30 is what? Root 3 over 2 over sine 60. That's over root 3 over 2. Now, we just continue. This becomes 2 root 3 plus root 3 over 2 over what? Root 3 over 2. So, to be at the safer side, I won't like to stress myself here. I'll be as fast as possible. Here, I think you all believe me that I can write this as 2 root 3 over root 3 over 2 plus root 3 over 2 over root 3 over 2. So that means that I will divide this with this. I'll also divide it with this. So here, to get this my answer done, I think you still believe me that I can write 2 root 3 divided by root 3 over 2 plus here, this root 3 over 2 here 1, root 3 over 2 here 1. Here, I'm going to have 1. So I'm now going to say 2 root 3 times what? 2 over root 3 plus 1. And the next thing I'm going to have here, after doing this, I know that root 3 here 1, root 3 here 1. What do I have left? 2 times 2, which will give me 4 plus 1. And 4 plus 1 will give me 5. So the end of this my word simplification is just going to give me 5. As simple as that. So we now move on to the next one that we have here. This is that from an aeroplane in the air at a horizontal distance of 1050 meters. The angles of depression of the top and base of a control tower at an instance are 36 degree and 41 degree respectively. Calculate correct to the nearest meter the height of the control tower. Secondly, the shortest distance between the aeroplane and the base of the tower. So now, it's very simple. Let's assume that this here is my aeroplane. Let's assume my aeroplane. Let me use A to represent aeroplane. And then I'm going to use the tower. Let's assume this is my tower. I'll use this place as the top of my tower. Now let me call this point C, which represents the top of my tower. And let me call this point B, which represents the bottom of my tower. So now, this is the position of the aeroplane. And we all know that in order for us to find the angles of depression, a line, the angle that is being made by this object that is moving at from this horizontal level to this what? To this end. We have this end like this. This angle here is known as what? My angles of depression. And this is the horizontal view of the what? Of the aeroplane. And as it is moving down, looking downward at the top of the what? Tower, the angle in which with which it makes to the what? To the top of the tower is what? 36 degree. I'm going to write 36 degree. Also, it's also what? The angle of depression of the aeroplane to the bottom of the tower is 41 degree. We have something like this. So the angle here we have it to be equal to what? I mean, the angle that we have here is what? 41 degree, as is being stated from the question. Now, they now say that what? The distance between the what? The aeroplane and the top of the tower. Remember, they say that the distance from here to here is what? 1050 meters. So the best thing for us to do here, we just have to give it a what? A good lettered work. So we just have to give it a good letter. If this is A, B, T, let me just call this point N. And they now ask us to find the height of the control tower. That means they ask us to find this height, TB. They ask us to find this height, this small h. And they also ask us to find the total height of the tower. That's from here to here, which is capital letter H. So, and in order for me to get this small letter H, I need to first of all calculate my capital letter H. My capital letter H is the line BM, while my small letter H is what? Is the wing height of the tower that they asked me to calculate, which is TB. And it's very simple. In order for me to do this, I need to what? Calculate this capital letter H, which is BM. And remember, the angle with which the BM make with the what? Horizontal view of the aeroplane is 45 degrees. So I'm now going to use where this 45 degrees is facing is my what? Opposite. And here the whole of this space is my opposite. I'm considering, let me just say considering, let us consider triangle AMB to get the what? The height of the aeroplane from the base of the ground. So now I'm going to apply what? Tan, which is opposite all over adjacent, because where this angle is facing is what? Is my opposite, where what? This is my adjacent, and here is my what? Hypotenuse, where the right angle is facing is my hypotenuse. So now, consider triangle AMB. I'm going to have tan 41 degree, according to what they have given us from the question, is equals to opposite. Remember, my opposite is what? H over what? Which is my total height of the what? Of the aeroplane from the horizontal base. Then all over what? Adjacent. My adjacent is 1050. So we just find my H is going to be 1050 times tan 41 degree. So if you punch your calculator very well, you're going to have it equals to 168. Sorry, is in radians. We have it to be 912.75 meters. So if I now approximate it to the nearest whole number, I'm going to, all right, the best way is for us to just leave it like this, since this is not what they are supposed to calculate. This is the height of the what? Aeroplane from the base of the tower. Now, but what they only ask us to calculate is the height of the control tower. That means that the height TB, which is the small letter H. Now, how can I get the small letter H? It's also very simple. Only what we just need to consider here is that for me to get the small letter H, we all know that the angle we have here, if from here to here is what, you just need to consider this triangle AMT. Yeah, to consider triangle what? AMT. Just say consider triangle AMT. So now, if you consider triangle AMT, I'm going to have tan 36 degree equals to NT, which is the opposite. Remember, we are considering this triangle that we have here, which is ANT. Here is 36 degree. Then MT, we don't know. We all know this to be 1050 meters. So I'm going to have it to be, here is my opposite that I'm looking for. So here now, you now need to look for this. I have my MT over adjacent, which is 1050. So my distance MT is going to give us 1050 when we cross multiply. So tan 36 degree. So we have 1050 times first value of tan 36 degree. We punch our calculator to finish this off. 0.7265. So if I press my calculator and multiply this by 1050, I have it to be 762.87 meters. So now, in order for me to find the distance of what TB, remember that BM is equals to NT plus BT. So that means that the length BM is equals to sum of this distance plus this distance. So now, and they asked me to find TB, which is the height of the control tower. They asked me to find the value of H itself. So, my BT is now going to be equals to BT, we just make it the subject of formula, is going to be BM minus MT. So my BT, which is the height of the control tower, is going to be, what was my total VM? That is my capital letter H, and we have found it to be 912.75 meters. I'm going to have 912.75 meters minus MT that we have looked for here. We have 762.87 meters. So now, if we subtract 762.87 from 912, we have something like this: 912.75 minus 762.87. So we have it to be 149.88 meters. So approximately, remember they say that to the nearest meters. So I'm going to have 150 meters. That's all about that. They just asked us to do that. And that is all about the height of the tower. The height of the tower we are going to obtain is going to be 150 meters. Just write it there to the nearest meter. Now, the next thing we need to do, they ask to find the shortest distance between the aeroplanes and the base of the tower. So, always remember that the shortest distance is the slant height. That means that the distance from the aeroplane to the base of the tower directly. So now, my shortest distance is the distance from the aeroplane. This my A represent my what? Aeroplane to the what? To the base. This is my base. So this line is represent my shortest distance. This is my what? Shortest distance. That means that the distance from the aeroplane, the line from the aeroplane to the base directly. So they're actually asking me to find my hypotenuse line, which is very simple. So what we do here is that, just try as much as possible. We try to consider this triangle. Just say consider triangle. We consider this triangle A and B again, A and B. But remember, this time around, I need to find my what? My hypotenuse length AB. But we all know that where this my H is my opposite, this is my adjacent, so I can use any one of them that I like. I can either use opposite over hypotenuse, which is sine, it will still give me the same answer, or I use adjacent over hypotenuse, which is cos. I'm going to get the same answer regardless of the two of the identity that I use. So now here, I can just try to use what? Sine. I will say sine. Remember, I'm using this angle from here to here. I have sine 41 degree. which is equals to opposite over hypotenuse. My opposite is h over my hypotenuse. That is what I'm looking for. AB. That is what h. Opposite over what? Hypotenuse. So I'm going to now say that AB is equals to h. What I did there, I just make AB the subject of the formula. Just like something like this, I can say this over 1, cross multiply. I have AB sine 41 degree is equals to what? H. And now divide both sides by sine 41. This is also by sine 41. So this here 1, this here 1. So my AB is equals to what? My H. We all know my H. My H has been calculated before to be equals to we have that's 912.75 meters. I have 912 point what? 75 meters over sine 41. So we all know the value of sine 41 to be equals to, let's look for that, sine 41. So that one is 0.6560. So if I divide it, I have 912.75 divided by 0.6560. So I have it to be 1,391.38 meters. Remember, they asked us to leave our answer to the nearest meter. I have 1391 meters. So if you can also try the one of cos. If you use cos, that's going to be cos 41, which is adjacent over hypotenuse. You're also going to get the same answer from there. So let us have a blessed day. Thank you for your time. Don't forget to like, share, and follow. Thank you. See you in our next class. Bye.